In this video, we will talk about serial and discrete naming. Let us begin with a little demonstration of what serial and discrete naming exactly refers to. So in the next screen, you will see digits appearing one by one, and your job will be to name them as fast as they appear. So if you see the number 2, you say 2, you see the number 5, you say 5, and so on. Try it. That was probably a little demanding, but not too scary. In the next screen, you will have to do the exact same thing, but now all the digits will appear in the middle of the screen. So fixate in the middle of the screen and just say each number as it appears. Most likely, this felt much more demanding than the first one, although the rate at which the digits appeared was exactly the same. You can go back in the video and time them if you don't believe me. Now let's look at the third condition. In this condition, all the digits will appear on the screen, and your job will be to name them one by one, starting at the top left and just going to the right, and then down in the same way as you would read. I'm going to bet that the last version was the fastest and easiest. So you could actually go faster than what you thought was too fast in the middle version. You could go much faster and with less effort. And it's not just because the digits are spaced out, but it's also because you had your own control of the rate. And when you took control, you became faster and it was also easier. So now you have experienced two versions of naming. The serial naming version, which is also called RAN, for Rapid Automatized Naming. This is the most frequent acronym. It's not a very good name, but pretty much everybody calls this RAN. And is this version, the one that you just did last. In contrast, the discrete naming is one where each item is displayed individually, isolated on the screen, and you have to name it. In doing this task in research, we actually don't present them at this rate that you just experienced. We present them one by one and wait for the participant to name them before we move on to the next one. So it's not a difficult task, but it ends up being quite slower than the serial one. And the reason that I presented them immediately one after the other was to give you the impression of how much more time you need in the discrete presentation compared to the serial one. Now, these examples have been with digits, and this is the version we use most often. However, you will see other versions also very frequently in the literature, for example, pictures. So this is a mus, bot, gut, der, and someone has to go through and name all of these in order. Or you can have colors, where you would have to do red, yellow, green, blue, and so on. And these are all different versions of RAN. So you can have RAN digits, RAN objects or pictures, RAN colors, and you can also have RAN letters, where you present arrays of letters for participants to name. There are very important differences between naming individual items and naming arrays of items in a serial fashion. So serial and discrete naming have two important differences. The first one is that serial naming time is less than discrete naming time. This means that if we take all of the times that somebody uses to name a series of items presented isolated, so one after the other, we measure all those times and we add them up, the sum is always longer than the time it takes to name the same items presented simultaneously in an array, in the serial time. So discrete naming time per item is longer than the serial naming time per item. And this we have called the serial advantage. The other difference has to do with the way performance on these tasks correlates with performance on reading tasks. Actually, how fast you perform the serial naming task is associated with how fast you read. And this association is much stronger between reading fluency and serial naming than between reading fluency and discrete naming. So serial naming of digits predicts how fast you read, how fluent a reader you are, whereas discrete naming of digits has a very weak prediction. This difference is called the serial superiority effect, meaning that serial naming is superior to discrete naming in predicting reading fluency. The serial advantage has been studying for a while, and we can see that it holds for a variety of possible stimuli. So this is the serial advantage for two different languages, English, which is quite inconsistent in its orthography, and Greek, which is more consistent than Norwegian. And we can see that there are similar patterns for children going to grade 1, grade 3, and grade 5. For English, also grade 1, grade 3, and grade 5. And what you're looking at here is the serial advantage. So how much time per item is gained by going from a discrete presentation to serial presentation. In other words, how much faster children can do the serial naming tasks compared to the discrete naming tasks per item. So it looks like children gain about a third of a second by doing it serially when they have to name dice, digits, number words. But they don't gain so much when they have to name objects and words, especially in first grade, and that's true for both languages. But by the time children are in fifth grade, words have jumped up with the other kinds of things, so it is actually faster to read words when they're in lists of other words than when they are by themselves. But objects don't quite make it to be that faster, although they're still faster serially than discrete naming. So there is a serial advantage, and words gradually conform to this advantage as children become more experienced readers. What about children with difficulties in reading? Here are some Italian data comparing typically developing readers with children with dyslexia. And all children had to name digits, colors, and to read shorter and longer words. And each of these they had to do for single stimuli, which is discrete naming, or multiple stimuli, which is serial naming. So single means you show one thing at a time, that's discrete naming. Multiple means you show them all simultaneously and the participant reads serially. So we see that for typically developing readers, serial naming is always faster. They need less time, less reading time per item. for typically developing readers. For children with dyslexia, they need less time for serial than discrete naming of digits and for serial than discrete naming of colors, maybe with less difference from discrete than the typically developing readers. But the most important thing here is what happens with words. So there is no serial advantage for words for children with dyslexia, and when we go to longer words, there is actually a serial handicap, as if the adjacent words are actually distracting the children with reading problems and slow them down further than what they would read if they could only see one word at a time. Why would there be so big differences between discrete and serial naming? Why would there be a relationship between naming digits and reading words? And why would that have to do with reading problems? Let us imagine how one might go about naming individual or multiple stimuli. The following animation shows a hypothetical situation of having to name a single digit. So this is a discrete digit naming. What must happen is that the person must look at the digit, process it visually, map the visual form to the corresponding word and its pronunciation, and then execute the articulatory plan to say the word. What about serial naming? The following animation shows a hypothetical situation of having to name a series of 4 digits. So no one can really open somebody's head and see that this is happening. But the idea here is that when you have multiple things to name, it is possible to run them through a pipeline so that when you're looking at one, you can be converting the previous one and speaking the one before. This means that you're essentially dealing with multiple items simultaneously, although you're not doing the same thing with every item at the same time. This we have called cascaded processing, and it is possible that this is why serial naming is related to reading, because in reading, we know that the eye looks ahead of the word that you're saying, therefore intermediate words must be buffered. It is possible that the ability to run this pipeline concerns a distinct skill domain that may underlie the crucial difference between serial and discrete naming, as well as the relationship between run and reading fluency and reading difficulties.